Welcome back everyone to another video. Now in one of my first videos about the HiKey 960, I did mention that and this is something that I'm expecting to see day after day on this board because this is still very much in development. So keeping that in mind, keeping the trend that is being followed of the software for the HiKey 960 being continuously improved, and today I want to show you guys something similar, and that is to do with the thermal setup of the HiKey 960, specifically the thermal driver. Now in a very recent update to the kernel, to the Android kernel for the HiKey 960, that is hosted by Google at Google Source, and that kernel recently received an update that enabled the temperature sensors within the CPU to be visible to us, and for them to have a driver and to be visible on the user end. So now we can actually go ahead and monitor those temperatures and take a look at how the thermal throttling and how temperature affect the performance of the HiKey 960, at least on Android for the time being. So with that said, let's go ahead to our setup. So for we'll be comparing it against, of course, without any fan. So our no fan setup is simply just the copper heatsink that was already provided with the HiKey 960. It is provided inside the box, and that is what was already installed, and that is what I'm using. So that is just simple passive cooling. There's no airflow and there's no fan to force a bunch of cool air right onto the heatsink. It's just being passively cooled by that very slim heatsink. Let's quickly go through the results. So without any fan on the single core test, now on Geekbench, up to 50% it is it is a single core task, and up to from 50 to 100, those are the multi-core tests. So up on without a fan up to the single core task, we had the CPU at around 60 degrees Celsius. 60 to 70 did range a lot, and then on the multi-core side we were continuously hitting the 85 degrees Celsius limit, which I think is the limit because it barely moved over 85 degrees Celsius, and as soon as it hit that limit we were throttling back very aggressively to the lowest clock speed possible. So 85 degrees seems to be the top limit, and again on multi-core we were easily hitting that without the requirement of a fan. Now talking about while the fan was there, with the fan the temperatures were on a single core pretty much untouched. They were the same for some reason, but on the multi-core side we saw a huge drop from 85 degrees to somewhere between 70 to 60. Now this is actually really impressive, and this actually results in a big performance boost, as we'll see. So let's go ahead and take a look at the scores. So without any fan on a single core score, we get 1495, which is nearly 1500, and without any fan on multi-core we get almost spot on 3000. Now let's take a look with scores with a fan. With a fan on a single core we get around 1573. Now I did get eventually a 1600, so the scores can be a bit varying, but you can see there is almost a jump of 100 points on the single core side of things. On the multi-core there is a bigger jump of more than 1000 points, and that translates a lot into performance. In comparison, when we had the fan on and when it was being actively cooled on a single core, our scores were more than the Galaxy S7 that was powered by the Snapdragon 820, and on the multi-core side it was actually a lot more than the Exynos powered Galaxy S6 powered by the Exynos 7420, which has a higher score than the Snapdragon 820 that powers the S7. So it was way more than the Galaxy S7, and then again more than the Exynos powered Galaxy S6. Whereas without the fan we were still on the same page with the single core performance coming a bit more than the Galaxy S7 powered up by the Snapdragon 820, but on the multi-core side we really dropped down to just above or almost equal to a Nexus 6P, which is actually powered by a Snapdragon 810. So yes, there is a big performance improvement, and the recent developments in the code in the driver area has helped me to get these results. Earlier I was planning on doing the similar experiment with external temperature sensor, but the results were not really accurate, so I waited for this to happen. And thank you for all the developers who have helped me over at the Bugzilla page for 96 boards to get this setup working. And that's about it. Another awesome recent development in the code. Now I do expect the scores to be a lot higher. People on the forum are saying that the score for single core should be as high as 2000 points. Now with that being said, this will take some time, some more optimizations on the kernel side, but for now, if you want even better cooling, I would not recommend using the provided heatsink. Now the reason I used it was because it was already applied and I didn't want to go in there and remove it with and end up damaging the components. So if you are actually planning on buying this, buy a heatsink that has a bit larger fins. The heatsink on the provided with the 960 is not really designed to allow much airflow because the fins are actually really tiny. Now on the heatsink that I have on my Raspberry Pi, you can see that the fins are actually fairly long and fairly dense, which actually allows for a lot of air to flow through and take the heat away with it. With that being said, that heatsink is actually really easily available. I bought it from RS Components. You can go ahead and search it on Google. As per the fan I'm using, you can just eBay or Google the term Raspberry Pi fan, and that 5-volt tiny fan would show up, and that works as well. So as long as you have a proper heatsink. Apart from that, you can try and experiment with fans that have a lot of a larger area and a much higher rate of airflow. Apart from that, you can also go ahead and try different configurations like pull in and push for the airflow and how that works on different cases. So that's about it. Thank you so much for watching, and I hope you really enjoyed this video, and I'll see you all in the next one. I have some really interesting stuff about the HiKey 960 lined up, and I'm trying to get it prepared and out as soon as possible. Thank you so much for watching, and I'll see you all in the next one.